Hi, we are going to be talking about kinetic energy and the work energy theorem. So, sample problem number 1. You throw a 20 Newton rock vertically into the air from ground level. You observe that when it is 15 meters above the ground, it's traveling at 25 meter per second upward. Use the work energy theorem to find A, the rock speed just as it left the ground, and B, its maximum height. So it's kind of a clue that we just mentioned. It's work energy theorem. So you're going to be defining work energy first and what that theorem is. And then knowing that statement, you can actually begin solving for the rock speed, which is the velocity, and its maximum height, which is your h or your y. Okay. Now, let's identify it first. Your work here, okay, because this is just throwing, your work here is work done by your gravity equals your change in K. And the one that is moving here is a rock, so change in K of the rock. Now, the work done by gravity here is actually negative since it is in the opposite direction to the displacement of the rock. If you remember, if you've got a force, let's say going to the right, and the displacement is going to the left, then the work must be negative because force and displacement, they're not along the same direction. So here it is, the work is negative. So from here, it's similar to work equals K2 minus K1. Change in K is just K2 minus K1. So since we know it by now, the definition and why we must put work as negative, we can put here, okay, let's begin here. That would just be work, gravity, equals K2 minus K1. This is a minus. All right, we know that K2 is 1/2 mv, in this case it's 2, squared, minus 1/2 mv1 squared. Right, and here, because it has to do with gravity, that is actually negative mgh equals. So from here, I can definitely get my v1, because again, we don't have any v1 here, and that's what we're looking for. So I'm looking for my v1. So what would it be? My v1 would just be negative mgh minus 1/2 mv2 squared equals negative 1/2 mv1 squared. So transposing the negative, I could just have positive here, making this positive as well, and this one as well. So that would just give me mgh plus 1/2 mv2 squared equals 1/2 mv1 squared. And then divide everything by 1/2 m, 1/2 m, and then square root as well. So I don't have any. Okay. So once I have the square root, I'm just going to cut it a bit short here. I just need to put square root here. I would put it as dash lines. Okay, square root. And then you would remove the squared because there's already square root. Okay. So that would just give me v1 equals square root of our v squared, v2 squared, plus 2gh. Plus 2gh. And so that is our v1. Now, knowing that that's our v1, we know that our v2 squared is actually 25 m over s. So that's 25 squared plus 2 times 9.8 times our 15. meters. Please be careful. If you need to convert, please do so. That would give us 30.3 m/s. That is for letter A. Right, and for letter B, we're looking for the maximum height, which is V2 equals 0, because that's the maximum height. Okay, for letter B, what is your H max? Oh, sorry, it's question mark. What's your H max? Let's go back to the equation a while ago. That's just negative mgh equals 1/2 mv2 squared minus 1/2 mv1 squared. We're looking for the h here. So just transposing, I just need to divide everything by mg. For negative mg, cancelling the mg, I'll just be left with h equals, I'm going to be also cancelling my m here. So I'm just going to be having, instead of having 1/2 mv squared, okay, this is a bit of a shortcut, but this is just transposing and dividing. I'll get v1 squared minus v2 squared. Instead of having 1/2 over there, I'll have 2g down here. So from there, I can have my v1, oh, I'll go 30.3 squared minus our 0.0 squared. Why is it 0.0? Well, at h max, your v2 is actually 0.0 m/s. And if that's the case, then just plug it in here. 9.8 equals 46.8 meters. This is another problem regarding kinetic energy and the work energy theorem. A 30 kg crate is initially moving with a velocity that has magnitude 3.9 m/s in the direction of 37 degrees west to north. How much work must be done on the crate to change its velocity from 3.9 to 5.62 in direction 63 degrees south of east? We're looking for how much work must be done. So let's identify this. Again, work energy theorem is just the total work equals your change in K. In this case, kinetic energy of your crate. Simplifying, that is just K2 minus K1. Further simplification, that would just give us 1/2 mv2 squared minus 1/2 mv1 squared. All right, now we've got here constant 30. It means the whole problem, our 30 kg crate does not really change. So you might as well make it 1/2 m v2 squared minus v1 squared equals 1/2 30 kg times our v2, which is 5.62, minus 3.9 m/s. I almost forget the squared here. Squared here. All right. Plug into your calculators. We just have 245.6 joules. So that is the work you need to change the velocity to your final velocity, or your VF or V2, equals 5.62 m/s.